butter. For completeness sake, or being able to get it done really quickly, we're just going to look up a peanut butter icon image and pull it from the web. So if we go to just a peanut butter image, I can just go grab some peanut butter. This one looks fine enough to me. And I'm just going to copy the address, and we're going to use that as the icon. All right, so now we have the title. We're going to say vote for your favorite type of peanut butter. That's going to be our full title, and then the description is vote between crunchy and smooth peanut butter. All right, so now we have this label. We can add something. This will be for a button. We'll just put it as vote for now. We're going to have to do some extra work in order to make it actually usable on the Blink, but I just want to showcase what it looks like. All right, so in order to return this response, we're going to return response.json and give back our action metadata. So there's our response. Everything's good. Now, we have this get response, and let's go test it real quick. We can just refresh this get request. We can see, hey, there's a nice little JSON that got returned. It has an icon, a title, description, label. Perfect. We have everything there. Now let's actually see it in the Blink. So in order to do that, there's a website called dial.to, and you would do, to test locally, the query parameter is action, Solana action, colon, and then whatever your localhost API is. Ours is localhost 3000 API vote. So let's go look at it. All right. So this is what's going to load your actual Blink so that you can view it and see what it might look like on a social media like Twitter or Reddit or whatever. Now you can see it's not loading. Now I meant to go run into this error, and you'll see that it says something about CORS. Look at that. All right, so the vote ran into a CORS error. This is because, what is it, cross-origin resource sharing. It's to help protect you. We're going to do some things to get rid of this error, and this is just a common error people run into with Blinks. So let's go ahead and add that. What's really cool is we can just add this as headers, and it should be part of what is in the Solana Actions SDK, which provides a very nice headers for you to already use. All right, so what you would do is you would have headers, and you would have actions, CORS headers. You can see it's coming from the Solana Actions SDK. And so that should now give you all the information to properly serve your action via a Blink. All right, let's go look at it within our dial.to. There we go. So we can see right here is we have our nice little image of the peanut butter. We have the title, vote for your favorite type of peanut butter. And then the description, vote between crunchy and smooth peanut butter. You can see that this part says the action has not been registered. Part of the whole system for onboarding Blinks today onto social media is you have to actually get your action registered via some kind of registry out there. There's one that's managed by Dialect. There might be more by the time this video is live. Basically, it's not registered. It's, hey, use at your own risk. We don't know what this actually does. That's okay for now. So we have our Blink. This is what it looks like. Looks really great. If we hit vote, nothing's going to happen. It's going to say failed to fetch. And that's because whenever you do the vote, we can see here via the network tab, it's going to try to, well, one, it's going to do a CORS error, and then it's also trying to do a post, and it's failing. So let's go ahead and go through that. So one thing to note is that as part of the full end-to-end for getting the post, we're going to also have to create an options return request. And what we can do with that to make it very easily is we can just make it equal to the get so that it knows everything that it needs to do. So let's go ahead and do that real quick. All right, so in order to do that, you would do export const options and just make sure it equals the get. And so now when we go back over here and we refresh, let's go inspect, it should just fail the post now. There you go. So the post failed, the method's not allowed. It's because we haven't created the post yet. Perfect. We're running into all the errors that we expected. Now we actually have to create the post. But before that, you notice that our get request just has vote. This is actually not voting between crunchy or smooth peanut butter. It's just vote. That's not enough information to present on your Blink for someone to make a good enough action. So what we're going to have to do is, if you look in the actual documentations, is there's something called links, and there's these linked actions that basically give a list of related actions for this user to possibly perform. So let's go ahead and add that real quick. So we're going to do linked actions, and it's a list. So links. It's going to be a list of possible actions. So let's create a actions list as well. This is going to be linked actions. Whoops. And let's go ahead and look at that and see what it's supposed to look like. Just as an example, it's always good to figure out what these things are supposed to look like ahead of time. So you can see here the interface for a linked action has the endpoint for the action, has a label. This is different from the original label we had, and a parameter for acceptable input if you want to give input on the actual Blink. So we're going to have the action, and we can see it's a list of linked actions. We can see here it's already bringing some things up. We can pull these out because it's only, let's say it's only href and label. And we have this vote crunchy and vote smooth. So we're going to do vote candidate equals crunchy as our query parameter, because we're not going to create different posts for each of them. And vote candidate equals smooth. Close the bracket, and we should have everything else. Cannot find name action, that's okay. Let's figure out what's going on. Property of missing action, required type linked actions. So let's go ahead and update this so that the compiler is happy, and that'll just be fine. So the way that it's actually supposed to be is it's just because I had a bracket instead of curly brace. So now we have the total actions that some user can perform. We have the label, the original label of vote. It's not going to be used anymore. And then we have the links and actions of what someone can actually do. So let's go ahead and do that real quick. Let's double check. Yep, we can see all the extra information. And let's go look at our Blink, see if it's updated. And you can see right here, we have a vote for crunchy button and a vote for smooth button. So now our Blink looks as expected, and we have everything set up on the metadata in order to execute our Blink correctly. Now, as you probably can guess, still will fail with a 405 on the post because we have yet to create those posts. So let's go ahead and get started on that. So we're going to create one single function, export async function post. And we're going to get the information from the request from specifically the URL parameter so we can understand whether or not the candidate is going to be a crunchy or smooth peanut butter. So you can see there's already Copilot is already trying to give me some information. I'm going to ignore it because I want to write my own. All right, so the way that we do this is we would first grab the URL, and this would be grabbed from the request that came back. Next, we're going to grab the search parameter, which we had as candidate, as we saw up here, the candidate equals crunchy. And now we need to make sure that the candidate given is actually a valid candidate. So let's make sure that the vote is either crunchy or smooth. That way we have a good return back to the user. And if they somehow enter something wrong, it's not going to give them a weird error. We don't want to we don't want to surface strange errors that don't make sense to the user. All right, so we're going to do if candidate is not equal to crunchy and or smooth. We want to say invalid candidate, return status of 400, and headers will have to also, once again, be those action course headers. Otherwise, it won't work. All right, so we've done all of our testing or our validation of input. We now have our candidate. Now we have to actually create the transaction to send back. So in order to create transactions, we're going to have to need a few things. We're going to need a block hash, we're going to need the message, and we're going to need any signatures that we possibly need to be added to that transaction. Thankfully, this transaction does not need any signatures on the server side. Sometimes maybe you want to sign something server side. In this case, we don't care. So I'm going to create a connection. This will be part of web3.js. And we're going to have a connection off of HTTP. It's going to have to be 127.0.0.1 at 8080.99. This is our local test validator. And we're going to use the confirmation status of confirmed. And so what it's a commitment status. So commitment status, what that means is we have a few commitment status levels. There's a process level, there is a confirmed level, there's a finalized level. So those levels are telling you how certain they are of a transaction making it on the cluster. The processed ones, hey, I found it. It's not yet confirmed. Confirmed means it's confirmed by 66% of the actual cluster. And then finalized, it's confirmed by 66%, and there's been 31 blocks afterwards that were also confirmed. So finalized takes a lot longer. Confirmed is generally safe. At the time of recording, there's never been something that was confirmed that didn't make it to finalized. All right, so next up, what we're going to have to do is we have to grab all the information that we need to from the URL, namely the account that the user signed with on the Blink, in order to create the transaction successfully. And so the body of the post request, if you go look at the post request that is being built over here, so let's go look at the body of the post request. Payload. You can see that it's giving my public key that I have tied to this wallet to be used. So we have to go grab that right here. So it's going to be body of type action post request equals request.json. And I believe it's going to be, this is a promise. Yeah, so it returns a promise. So we need to await it. And so now we have the body. Now we need to go grab the account. So const voter equals body dot account. So this will have a type of account on the body. Now we want to make sure that this account is an actual valid account. So one thing that we can do real quick is we can do new public key, because we know it should be a public key, on the body of account. If it's not a public key, this will error, and that's fine. That's to be expected. So cannot find quick fix, just import it on web3.js if you haven't already. Now, if this does error, we want to make sure that it errors gracefully. So let's go ahead and add it over here. So I'm going to do we're going to do a try catch right up here. And I want to make sure that the voter is actually a public key and give back an error that makes sense. So we're going to return right over here, or we're going to try to make voter equals new public key body account, just like we did up above. We'll move it right over here. So if that passes, we can just move on. If it doesn't, we want to make sure we return a valid response. So it's going to be invalid count, 400 bad request. Same once again with the course headers. All right, so we have that error. Perfect. Now let's actually start building that transaction. Now, if you remember from testing, and I can just pull this up real quick, we used basically a vote program in order to initialize the candidate. We did some information on, let's say, on voting for the candidate. What we're going to need to do is we need to grab specifically this method right here, and we need to pull the instruction. This right here right now just sends it out as an RPC call. We don't want to do that. We want to actually use it as an instruction. We also need to make sure that we are adding the signer correctly and it equals the account versus us signing on the server side, because in our case, we don't care about signing on the server side. So we have to do exactly what we did with some additional differences to create that voting program. All right, so like here, where we are creating a provider, we're grabbing the IDL, the voting type, we're going to have to do the exact same thing over here. So let's go ahead and pull that out. So we're going to pull out IDL equals your voting JSON. I'm going to make sure that that's actually where it is. I don't think Copilot gave me the right answer. So this is going to be backwards, backwards, backwards. I think one more actually. Yeah, backwards, anchor, target, IDL, voting, JSON. So you can think of that, like this is a lot. What's great is about on Next.js, you can just do this and it will pull you back to the web folder. Then you can just go back and move into the anchor. So we have the IDL, perfect. Now let's go also import voting, the voting type. And it's from target types voting, just like we did in the test. So now we have the voting type, we have an IDL, and now this is where it kind of different. It's a different thing because we need to create a provider to create this program. And we don't actually care to have a bank run provider because that's used for tests. We need to make sure that we use the right anchor provider in order to create our program on our specific post request. All right, so up here, what we're going to have to do is create the program. So program of anchor.program voting, because it's our voting program, equals new program. Don't actually think we need to do this anchor thing because we already have it imported, which is nice. Let's pull it in. New program of IDL, and it's asking for a provider. Our provider is just going to be our connection. So we need to make sure that this is after when we create the connection. All right, so let's go look at what the error we got. Looks like it doesn't really know what this is. So let me go, expression is not constructible, no construct signatures. So this is probably something to do with Next.js. So part of Next.js, what you're going to have to do is you actually have to go update the Next.js config in order to properly do it. Also, I have two news here. It just worked out of the box. So normally, in case you run into this error, because sometimes you will, you're going to have to update the Next.js config in order to properly compile this correctly. This one we didn't have to because it seems to have recognized it perfectly. It's great. But just as a note, if you're running into problems with this specific one, you can just look it up. It's a common error. You'll just copy and paste your error, and you will be able to find it very quickly. But we have the program. Now we need to grab the instruction for voting. So we're going to grab the instruction right here, and it's going to be program.methods.vote. And if we remember from our counter spec, our test earlier, we're going to need to vote, we're going to need our specific ID and the actual smooth or crunchy. So let's just double check, smooth and crunchy. We want to make sure that it says crunchy capital and smooth capital, otherwise it won't be pulled in correctly via our smart contract. So we have crunchy and smooth. So we're going to go put that in there. That's going to be the vote. It's going to be the candidate if we set it correctly. Yep, candidate. So we're going to vote the candidate and then new anchor dot, .bn of 1, because that's going to be the same thing as we had earlier, anchor bn of 1, so that we have the right information of the poll ID to give. So it's saying that I haven't imported it, so let's go import anchor real quick. Actually, we can probably just pull in bn. Let's just pull in bn from anchor. That would be even better. There we go. So we have the vote. The last thing is we need the actual instruction, because we're not going to be calling the RPC. All right, so we have an instruction. This returns a promise of instruction. Let's just await it because we don't want to just have a promise. So there we go. We have our vote instruction with the given candidate. Now, the one thing that we don't have on here is we don't have the accounts. So one of the accounts that is required is we're going to require the signer. And the signer is going to be the voter. And so that's all we need to add is the signer account. This is so that the instruction knows that, hey, I'm not signing it here. You're going to be signed somewhere else. And we should validate that the signer equals the person that passed in the original request via the blink. All right, so we have the instruction. Now we need to get a block hash. So let's go ahead and const block hash equals, it's going to be await get recent, not get recent block hash, but it's going to be a different RPC call. Let's go pull that out real quick. So not get recent block hash, but get latest block hash. And so this will give us some context. You can go look at this return. It has basically it tells you whenever this block hash expires. If we haven't learned already, block hashes expire after 150 confirmed blocks. So if you're trying to use it and it's too late, it's gone. This is to prevent replay attacks on Solana. It's all good to go. All right, so now let's create our transaction. So const transaction equals new transaction dot add instruction. And so this is a new type of a new transaction. It's going to say that I need it from Web3 address. There we go. We have the instruction. Now we're missing some things on this though. We have to be able to say, hey, what am I expecting and what's my block hash? So let's go ahead and add that as well. So the way that you do that is in here, you're going to add some information. You can see that it already knew some of it. It's going to be the block hash and the fee pair, but you can see, oh, this is not a valid thing. It's because it's a deprecated constructor. The one that we're going to be using is, I believe it's this one. Let's go pull that. So we need the fee pair, the block hash, and the last valid block height. So let's go ahead and add that. So we have block hash equal to that block hash, and last valid block hash, block height, which will be block hash, and there should be a last valid block height on the block hash we got earlier. There we go. So we have the transaction now. And finally, we have to return it as an actual response back to the user on the blink. All right, so let's go ahead and do that. We're going to do const response equals await create post response. This is a thing from actions. This is going to be a different type. So let's go ahead and pull that out and see what it expects. So it expects your fields. This field is just going to be the transaction. That's all we care about. So this is going to be of type fields transaction equals our transaction. All right, so we have our response. This is the fields that we have in it, just the transaction. And finally, we need to return it. So return response.json, and we always remember to add the course headers. Otherwise, it's always going to fail. All right, let's go ahead and test it out and see if we did everything right the first time. All right, so we'll go refresh this blink. We can see here it has the vote for crunchy and vote for smooth. And if I click one of them, it should pull up my wallet in order to sign for the transaction. There we go. All right, so we're here signing for the transaction. If you run locally, there's going to be a lot of information here. What you find usually with wallets is that they're not doing any like caching on local; they're just skipping it. We can just confirm it because we know that we're working on local. Oftentimes, if you do see these errors, though, I would not confirm your transaction, just as a general FYI. So let's confirm it. And you can see there's a bunch of errors showed up, but that's okay. The response got back as 200 OK. And these errors are just the wallet was unable to figure out what was going on. And so we have now an end-to-end blink. So let's go ahead and check that on our Explorer. So let's go pull up the transaction history. And we should be able to see different transactions on this program. So looking at the program, let's see if we can refresh a few times. All right, so let's go ahead and figure out what might have went wrong. All right, so the reason why this did not work is because what's happening is we're doing this transaction. Everything is correct here. We have all the correct information. However, we have a poll ID of 1. Now, if you remember, we just deployed our program earlier, our smart contract, onto our local test validator. We don't actually have any information about this actual smart contract or this poll or these candidates. So we actually have to create those. And a very easy way to create those is you can just run your test. And if you write your test correctly, which we did earlier, this should be able to create the correct candidates of smooth and crunchy for people to vote on. So let's go ahead and run that real quick. And the way that you would do that is anchor test skip local test validator. Skip local validator. We'll allow it to deploy. That's fine to me. So it's going to deploy to our local test validator, and then it's going to run all of our tests. And these should set up our specific poll onto our local. So it looks like that they're not pulling. Oh, it's because it uses a different program ID than the one that we actually deployed. So we can go pull that right here. So you can see it's not ELY, it's actually 6RM. So we just have to replace that, and that's fine. So let's do that again. Anchor deploy, and then we'll run the test suite. And we can see, let's see what would fail this time. Declare program ID mismatch. So this is saying that something did not match correctly to where the program that was provided did not equal. So the reason why this vote for crunchy and vote for smooth button does not work is because we never set up our poll ID or our poll and candidates early on. If you remember correctly, we were using Solana Bank Run in the previous project to do a bunch of tests. We then, early on in this project, when we started, we deployed our smart contract onto our local test validator, but we have yet to actually set up any of the configuration in order to create our votes. So let's go ahead and start doing that. So I'm going to do it via the test. We're going to change some things. I'm going to remove this code right here, and we're going to use the test to set up our configurations. So we have the vote program. This vote program is going to be equal to a new thing for our anchor, using our anchor workspace. So what we do here is we do it as anchor.workspace voting as program voting. So this creates our correct program. And the second thing is we're going to have to make sure that we're setting the provider correctly to run locally. So set provider. This is going to be a specific different provider because we're doing it locally. So this provider is going to be anchor.anchorprovider.env. All right, so now what we can do is, and sometimes if you don't do this, you'll have to do an anchor clean. This will clean up your workspace, make sure everything is set up for success. I'm going to go ahead and do that as well. And then we have to run it to where it's building the program, deploying it, running the test, and creating our configuration. So let's go ahead and do that. So once that completes, you should have a bunch of tests pass. And the test, you can see that, hey, we have all these crunchy and smooth peanut butter set up. And you can see here that there is all the program ran their instructions correctly. If you do run into error, make sure this public key is equal to the deployed program. You can always check what program public key that you are set up, but make sure it is always equal. Otherwise, you're going to run into issues. So let's go ahead and test our blink real quick. All right, so let us vote for smooth. It'll pull up here, and it will send the transaction over to our account. Let's go over to our program account, and we should be able to see, if we did everything correctly, a new transaction that at the very end, it's voted for candidate smooth. Currently, I have 3 votes on my local one for smooth, and everything was created successfully. So that is how you use blinks and actions, a very quick tutorial of how you create blinks and actions with a application on chain. So to recap what we did is we took over our voting app from the last project. We extracted a lot of the code of how to interact with the program. We created a server-side component via Next.js to serve the actions and allow people to get these serialized transactions. And then finally, we were able to view the blink via Dialect's blink tester website and interact with it to test everything out. Everything seemed to work correctly. We were able to vote for our different peanut butters based off of what we liked, and it was all done via this blink. Now, if you wanted to take this to production, the specific blink, you would have to go through the registry and register it. And also, I'd recommend deploying this to an actual environment, maybe DevNet or even mainnet. And that way, other people can interact with it via whatever social network they please. But yeah, that's everything for this project, and we will see you in the next project.
Our next project will be a CRUD decentralized application. CRUD stands for Create, Read, Update, and Delete, which are the 4 basic operations of persistent storage. This is foundational and will help you understand data handling, smart contracts, front-end integration, and blockchain transactions. These skills are not only essential for blockchain development, but also highly adaptable to various real-world applications. These skills can be transferred to any sector needing decentralized solutions, like finance, healthcare, and more. Understanding CRUD operations on Solana allows for innovation, as you can modify or extend your application with more complex features in the future. So let's get started. Okay, so we're going to get started with using the npx create Solana dapp command because we're going to be creating a backend connected to a frontend. And this scaffold has your anchor program with a basic counter program, and it's already connected to a frontend for you using Next.js and Tailwind. So let's start that. We'll type into our terminal npx create Solana dapp, and you'll be prompted to enter your project name. So we'll just name this CRUD app. Oh, already exists. I've done this before. So we'll name it CRUD app 2. So we'll select a preset, Next.js, and we're going to use Tailwind for our UI library. And then here you can select an anchor template. So we'll do the anchor counter program with tests. And now it's going to be creating the workspace for you. This is going to take just a second to load, so we'll just wait for it to load. Okay, so now you can see that your scaffold is loaded, and you can actually see there's a command here that says found anchor version 30.1, please upgrade. So this scaffold currently is set to anchor 30.0, so we just want to make sure that we're on the latest version of anchor. So let's open up the scaffold. And here is your anchor folder, and the anchor folder is going to have all of your backend smart contract code. And for the front end, you'll have the web folder. So we'll touch the web folder later on. We're going to focus on anchor right now. As we just talked about, we need to update our anchor version. So we'll go into the cargo toml and update to the latest anchor. So here you see anchor lang is set to 30.0. We'll just update that to 30.1. And now looking through the anchor directory, if you go into programs, counter, source, lib.rs, that is where your smart contract lives. And what we're going to do is just update the counter to our CRUD app. So we're going to rename this. to be a CRUD app. And then in the librs, with this preset, you have a working counter. So you have close, decrement, increment, initialize, and set instructions. Since we're updating this to a CRUD app, we don't need it. So we're just gonna delete all of our instructions here and just have the basic layout for a smart contract using Anchor. And if you see all of these data structures underneath, they're all related to the counter program, so we can delete that as well. And now we have a basic layout. We're using anchorlang from our crate. And then this declare ID has a generated public key. This public key is going to be the program ID of the Anchor program that you deploy on chain. So this will always be your program ID. When you run Anchor build, it's going to update accordingly. Inside the program macro is where all of your instructions are going to live. So that's where we'll write the CRUD app instructions. But first, anytime I write a smart contract, I always want to start with the program state. And the state is where you're going to hold all of your data. So as you know, smart contracts on Solana are stateless. So all of the state is stored inside program accounts. So we're going to create an account for the CRUD app and define all of the data that we want to store. To do that, you can use the account macro with Anchor. So we're going to specify an account here. And then we're going to define the data structure. So I want this to be my journal entry state. Okay. Now, we're doing a journal here just because that's a very basic example of a CRUD app. In a journal, you want to create journal entries, you want to be able to update them if you need to, and be able to delete them if you need to. So we're just using a journal as our example. And let's see, what do we want to save to the state of a journal? We want to know the owner of the journal, so we can save that. And an owner is going to be of a type pub key because it's connected to your wallet address. When you're writing a journal, usually title it and you have a message. So let's save those as well. And these will be of type string. Okay. Now, when you're creating a account on chain and you have storage, you have to pay to hold that storage on chain based on how much space it takes up. So the rent is directly correlated to the space on chain. So we have to calculate how much space our state data structure is going to take up on chain. You could do this manually. Each type has a different number for how much space it takes up on chain, but Anchor actually does this for you. So we can use the derive init space macro to be able to calculate how much space is on chain. And you can see when we do this, we generate 2 errors, and the errors are for the string types. This is because strings can be infinitely long. So that's a little hard to calculate space there. So we need to set a max length for each string value. So for the title, that can be a little smaller. I'm going to set the max length of 50. Okay. And then you can see the error goes away. And I'll set a max length for message as well. And we'll say 1,000. Maybe you want a really long message. Okay, and now that error went away. So this is our state. Our state's defined. This is everything that we'll need to store for a journal entry, and it's going to live inside our journal entry account. We need to create this account. We need an instruction to initialize a journal entry account. So that's what we're going to do next. That will be our first instruction handler. We're going to do a pub fn create journal entry. Whenever you're writing an instruction for Anchor, the very first parameter that needs to pass through the instruction is going to be your context. The context macro is used to define a struct that encapsulates all the accounts that'll be passed through a given instruction handler. So we're going to write a custom struct for this instruction. So we'll write the context. And then we'll name the struct create entry. Okay. just setting up the instruction here, we'll write the logic after we define our struct for this context. So we can go back down here and define that. Now that we have the instruction, we're going to define the struct for create entry. So pub struct create entry. When you're defining your context data structure, you need to define all of the accounts that are going to be passed through the given instruction that you're writing. So the first account that we're going to need is the journal entry account, and that is for the state that we just defined earlier. So to do that, you can use the anchor account macro, and then we're going to add some constraints on the account for how we want to handle this account throughout the instruction. So the first thing we want to do is we want to initialize the account. We're initializing the account because it doesn't exist yet. So we'll use the init constraint. And then we want to have a PDA on this account. So we're going to define the seeds for this PDA. So there's about infinite ways that you could define a PDA. Here, I think that the best way for us to do it is specifying the owner and then another parameter. And that's because we want to know who each journal entry belongs to. So having the owner connected to the PDA is a really easy way to derive that. If we just had the owner wouldn't be able to create more than one entry on chain. We need to add another parameter to allow them to create more than one entry. So we can do this by adding the title. So if we add the title, the owner can go in and create multiple entries based on the title. We're just going to add that for our seeds. We'll do title as bytes. And then we'll add in the owner's key. As ref. And now our seeds are defined. Anytime you define a seed, you always have to add the bump, so we'll add that here. And now, since we're initializing an account, we have to be able to calculate the space that it's going to take up on chain. This is needed so we know how much rent that we have to pay. So we're going to define the space. And whenever you're calculating space, you always start with 8. 8 is the anchor discriminator. So we'll add 8. And then for the rest of the values in the given journal entry struct, we can just calculate that by using init space, since we use the derive init space macro here. So we'll do journal entry state, init space. Okay. And now, lastly, we just need to define who's going to pay the rent. So we need a payer. And we'll make the payer the owner of the journal entry. And then all that's left here is to name this account. So we'll make this a journal entry of account, and it's going to be using the journal entry state. Now that we define that the payer is owner, we haven't specified who the owner is yet. So we're going to do that next as the next account in our create entry struct. So we're going to once again use the account macro from anchor. And we're going to specify who the owner is. So in our case, we want the owner to be the person who's signing the instruction. So it's just going to be the signer. Now, if you look at how our accounts are set up, we have the owner being the payer when we're initializing the journal entry. Because the owner is going to be paying, it's going to be changing the state of the owner's account. When that happens, we have to define that the account's mutable. So we're going to add the mutes constraint here on the account. And this is just because in Rust, all variables are immutable by default. So whenever we want something to be mutable, we have to specify it. And then lastly, we just have to define the system program. So system program, and we're good to go. So now you can see we have one error showing up on the account, and that's for title. Now, why is that happening? It's because we haven't specified what the title is yet, and we don't know what the title is going to be. So the title has to be a user input parameter. So we're going to go back up to the instruction, and we're going to add a parameter for title, and that'll be of type string. Okay. And now this is being passed through the instruction, but it's not being passed to this create entry struct. So to be able to get this data down here, we're going to have to specify that you're pulling the title from the instruction. And we can do that by using the instruction macro. So instruction, and we're passing through the title that's coming through from the instruction user input parameter. So now we're good to go for everything needed for our context data structure for the create journal entry instruction. Now we can go in and start writing our logic. So if we look at the instruction, we're passing through the context, always the first parameter. We're passing through a title, which is a user input value. And then there's one more thing that the user is going to be inputting on the front end, and that's going to be the message for their journal. So we're going to add that as another parameter. And that's everything we need there. So all that's left is just defining the logic for the instruction. And what are we doing when we're creating a journal entry? We're just saving information back to the account state. So that's all we have to do here. To do that, we're going to load in the journal entry account. So we'll let the journal entry equal. And we're making this account mutable because we're going to be changing information in the account. So mutable, and we can load that in through the context. So we'll do context.accounts, and the account that we want here is the journal entry. So you can see here, this is the journal entry account that we're loading in through our context. And Copilot knew what we were doing and just finished everything. So we'll talk through what Copilot just did here. We have our journal entry. And then all you're doing is updating the fields on the journal entry. So the journal entry owner, we're referencing the owner's key. And the owner, as we've defined here, is the signer of the instruction. We have the title and the message, which are both user input parameters of the instruction. And that's everything we need to save. So our very first create instruction is completed. So we can move on to the next. So a CRUD app, create, read, update, delete. Read is just querying the blockchain. So we're going to move on to update. And we're going to do an update journal entry. Okay, so as you can see here, Copilot is really great and already knows what needs to be done for this instruction. So I just tabbed over through the Copilot suggestion, but we have the update journal entry. The very first parameter that's being passed through is the context. Now we need to define what this data structure is for the context. So let's go down here and do the same thing we did earlier, but now we're going to be doing it for update entry. So derive accounts macro. And then we're going to do, update entry. Okay. Here, with the data structure, you want to define all of the accounts that are correlated to the instruction that you want to have the data structure for. So we need to pass through the first account. That account is going to be the journal entry account. So let's define that here. And we'll use the account macro. And we'll add some constraints to it. So here, the constraints are going to be a little different. It's already been initialized, so we don't need the init constraint. But we're going to be changing the state. So we need it to be mutable. So we'll define mute as a constraint. And then you always have to add in the seeds so it's able to derive the correct PDA of the account. So we'll do the seeds and the bump. And here the seeds should be the same as above, title and the owner's public key. And now there's one more thing that we have to do. As we talked about earlier, the rent for storage on chain is calculated based on how much space it takes up. So if we're changing the length of the title or the length of the message, it's going to change the amount of rent that a user needs to pay for space. So let's say we had a message that was only 10 characters long, and I want to go in and make it 100 characters long. I now have to pay more rent. And vice versa. Let's say I deleted 100 characters. Now I'm paying less rent and I want to get those extra land ports returned back to my account. So to do that, we're going to use the realloc constraint. And this is just reallocating space for a specific account on chain. So we're going to calculate the space here. So we'll do realloc equals and have the new space calculated. So 8 is the discriminator. And then we'll do the journal entry init space. And then whenever we're doing this, we still need to specify who is going to either receive the extra land ports that are being returned or pay more land ports that need to be given for more space. So we'll do realloc payer. And that payer is once again going to be the owner. And there's one more thing. So we can do realloc 0. And what this is doing is just setting the original calculation of space back to 0 and then recalculating everything. So we'll set realloc 0 to true. And then lastly, we're just going to define what this account is. So it's our journal entry account. Okay. Now, if you remember from before, this data structure doesn't know what title is. So we're going to have to do the same instruction title. So we'll pull that macro in. And then we're going to add that as a parameter here for updating journal. So title is also going to be a user input parameter for the instruction. So now we specified the owner, but we need to pass that account through as well. So we'll add that in. Same thing as we did earlier. So it needs to be mutable because it's going to be paying. And it'll be the owner, and the owner is the signer. And then the very last thing we have to pass through is the system program. And now our data structure for our update entry context is completed. So we can pass that through here for our update journal entry instruction. If you look at the instruction, we have this little warning under title. And that's happening because title isn't actually being used in the logic of this function. This is just a little Rust thing. We're going to just add an underscore here to say, hey, I know that this parameter isn't being used in the logic, but I need to use it somewhere else. So I still need to take it in. Everything here is done. We have our update journal entry. We're passing through both the title and the message. We're updating the message in our journal entry state. And we're passing through all of the corresponding accounts in our update entry data structure for our context. Creating the journal is done. Updating the journal is done. So all we have left is to delete a journal entry. So we can go in here and we're going to write out our instruction for deleting. Okay. So this time, Copilot has been doing pretty well, but this time it's not correct. So we're going to delete what it suggested here and just have this instruction returning an OK value. And that's going to happen because all of the logic for deleting an account on chain is going to take place inside the delete entry data structure for the context. That's because all it's doing is handling accounts. And all of the account handling takes place inside the data structure. We'll go down here and make another struct for deleting an entry. Okay. First account we're loading in, just like before, is our journal entry account. So we'll do the account macro. we're changing the account state so it's mutable. We need to specify the seeds and the bump so it's able to derive the correct PDA. So seeds, the same as earlier, bump. And then there's one last constraint we're going to add, and we're going to add a close constraint. So what close does is if you run this instruction, it's going to close the account. But it's only going to close the account if the public key that I specify the close to be equal to is the signer of the instruction. So I want the person that can close this to only be the owner of the account. So close equals owner. And we'll do define the journal entry. And then we're going to specify who the owner is, which is the signer. Okay. And then lastly, we pass through our system program. And then one last thing to pass through is the title, just like we did earlier. So we'll pull this macro down here and then make sure title is passed through, which it is. And look at that. Our program's done. So if you go here, you can see the create, update, and delete entries are completed in our program instructions. And you can see this little warning here for context, and that's coming up just like earlier with title. It's because context isn't being used in the logic. So we're just going to add an underscore here and say, hey, I know that, but I'm using it somewhere else. And then we have all of our context data structures for create, update, and delete. And then we have our state. And that's everything we need for a CRUD app. So we'll go in and we're going to build the program. So if I cd into my Anchor directory, I can just run Anchor build. Make sure everything builds correctly and compiles. Okay, so now you can see our program compiled, everything finished, and we didn't have any issues. If something goes wrong within your program, the Anchor compiler will be able to pick it up, give you a warning, show you how to fix it most of the time. But we have everything correctly done and built. Now that that's built, what happens is it builds and sends an IDL to your target folder here. So you can see that this is my new IDL. And this is named a counter still because I did not update the name in the cargo toml. So we're just going to go in there and update it to CRUD app. So we're just rebuilding with the name CRUD, just so we can have everything named the same throughout the application. Okay. Now we're good to go. So once we build the program, we're able to now deploy it on chain. Throughout this bootcamp, we're going to be using everything local. So I'm going to open up my terminal and run a local validator so we can deploy to our local host. So here's my terminal. And to get your local validator running, you're just going to run Solana test validator. And we're now initializing an instance of the local host. And you can see that the validator is running on my local host right there. So now that this is running, I can go in to my terminal within the CRUD app directory and do Anchor deploy. And I'm going to specify that I want it on local. So we're going to do provider.cluster local host. Okay, it's actually local net for Anchor. So if you're using the Solana CLI, it's local host. If you're using Anchor, it's local net. That's one fun fact to remember there. So you can see it's deployed. We have our program ID here.